In this video, we're going to cover probability, use of diagram. Names are find the probability of single event using tree diagram, two-way table, and Venn diagram, and tasks to check your understanding. At the end of this video, I would like to check your understanding, so I prepared a task for you. Comment below your answers or questions about probability use of diagram. You will see this task again at the end of this video. Here's an example for tree diagram. The frequency tree shows information about the lateness of students in school. Find the missing values. For this section, the total number of male students is 65 and late is 20. So we're going to look for the not late for the male. We will subtract 65 minus 20, and that's equal to 45. And that is for not late for the male. And for this section, the female students is missing, but we have the late and not late, which is 5 and 30. So to find the total number of students for female, we will add 5 plus 30, and that is equal to 35. So for the total number of students for female is 35. And for this section, we have to find the total number of students. Male and female are given, which is 65 and 35. So we will add 35 plus 65, and now we have a total of 100 students in school. Now we're going to use the tree diagram to answer the given problem. Find the probability that the student chosen at random is female. For the probability of female, that will be the total number of female students over the total number of students. Here we have a total of 100 students and 35 female students. So our answer will be 35 over 100. We can still simplify this. That is equal to 7 over 20. We can represent the probability into three types. First in fraction, second is decimal, and the third is percentage. So here is our answer, 35 over 100 or 7 over 20, 0.35 and 35%. Next is find the probability that the student chosen at random is a male who is late. So to find the probability of male who is late, that is equal to the number of male student that is late over the total number of students. And here we have a total of 100 students and total of 20 for the male that is late. So our answer will be 20 over 100, or we can still simplify this as 1 over 5. In decimal, that is 0.2, and in percentage, that is 20%. Here's an example for the two-way table. Let's read the given situation. The ratio of year 9 to year 8 students is 1:2. If a student who travels in a car is selected at random, the probability that they are in year 8 is 25%. Complete the two-way table. For this two-way table, in this column we have the year 8, year 9, and the total. For this row, we have the bus, the car, and the total. We have also here the 30, that is for the year 8 students who's using a car, and 100 for the total number of year 9 students. Now let's start using the ratio of year 9 to year 8. It says here it is 1:2. Now since the total number of year 9 is 100, we can multiply 100 times 2, and that is equal to 200. And that 200 is the total number of year 8 students. We can write here 200. For the next given, it says here, if a student who travels in a car is selected at random, the probability that they are in year 8 is 25%, which means if there are 30 students that's using a car, that's equivalent to 25%. Now we can find the total number of students who are using the car by multiplying 25% to 4 to make it 100%. And we have to do the same thing on the left side. We're going to multiply 30 times 4, and that is equal to 120. It means that there are a total of 100 students who are using a car. Now let's complete the rest. We can identify now the total number of students to year 8 and year 9 if we're going to add 200 plus 100, and that is equal to 300. So there is a 300 total number of students for year 8 and year 9. Now on this section right here, we can subtract 120 minus 30 to identify the number of students in year 9 who's using a car. So 120 minus 30, that is 90. And then let's complete the row for the year 8 to identify how many students in year 8 is using the bus. So we can subtract 200 minus 30, that's equivalent to 170. So there are 170 students for year 8 who's using a bus. Then for year 9, we can subtract 100 minus 90, so that is 10. So there are 10 year 9 students for the bus. Then for the total, we can add 170 plus 10, that is 180. Now let's use the two-way table to answer the given problem. A student is selected at random. Work out the probability that this is a year 8 student who travels on the bus. So let's identify the total number of year 8 students who travels on the bus. And that is 170 students. And then it says here a student is selected at random. So we're going to use the 300, which is the total number of year 8 and year 9. Now our answer will be 170 over 300. Now we can still simplify this, and that is equal to 17 over 30. In decimal, that is 0.56, wherein the 6 is repeating. In percentage, that will be 56.67% in 2 decimal places. Next is a year 8 student is selected at random. Work out the probability that this student travels by car. Now, we have a total number of 200 for year 8 students, and there are 30 students for year 8 that travels by car. So our answer will be 30 over 200, or we can still simplify this. That is 3 over 20 in fraction. And in decimal, that is 0.15. In percentage, that is 15%. Next example is a Venn diagram. Here we have 20 students were asked if they like English or maths. 5 students said both, 2 said neither, and 12 students said maths. Complete the Venn diagram to show this information. Here we have a Venn diagram that is 2 circles that overlap, and starting with the 5 students here who said both, so we can place it in the middle because they both like English and math. Then here, 2 students said neither, so we're going to put it outside the 2 circles because they don't like English or math. Then 12 students said it's math, Now, the complete circle here is equivalent to 12 students. So we're going to subtract 12 minus 5. So there are 7 students who like maths only. Afterwards, we have a total of 20 students. Now we can add all the number here, 5 plus 7 plus 2, that's equivalent to 14. Then we can subtract 20 minus 14, that is equal to 6, and that 6 is the total number of students who like English. Now let's use the Venn diagram to answer the following problems. A student is chosen at random. Calculate A. Probability choosing a student who likes both. Letter B. Probability choosing a student who likes neither. So letter A. Probability choosing a student who likes both. There are a total number of 5. That will be 5 over the total number of students, that is 20. Now we can still simplify this. That is equal to 1 over 4. So the probability of choosing a student who likes both is 1 over 4. Letter B, probability choosing a student who likes neither. And there are 2 students. So this is equal to 2 over 20. And still can simplify. That is 1 over 10. So for letter B, probability choosing a student who likes neither is 1 over 10. It's now time to check your understanding. Pause the video and comment below your answers or questions about probability use of diagram. And always remember, math is more than a procedure. It's a powerful habit of thinking.